Welcome and thank you for standing by. All participants will be in a listen-only mode for today's conference. During the presentation, we will conduct question and answer sessions. To ask a question, please press *1, unmute your line and record your name, or you can ask a question by clicking the Q&A tab at the top of your screen. Today's conference is being recorded, and if you have any objections, you may disconnect at this time. I would now like to turn the call over to Mr. Paul Gilman. Sir, you may begin.
Thank you, and welcome everyone to NREL's Modeling Wind Systems in SAM webinar. This is the first in a series of a few webinars on SAM that we're offering over the next few weeks. And I, Paul Gilman, along with Tom Ferguson, are presenting today's session. I also have colleagues on hand to help with the Q&A. So as the operator mentioned, if you've got a question, feel free to type it in the chat window, on the Q&A window, and someone is monitoring that, and we'll handle those questions. We're recording this session, and recordings of all of the webinars are available here on the SAM website on the learning page. If you scroll down to webinars, you'll see the schedule for upcoming webinars. This is today's, and then after we get the recording for today's session, which will take a week or so, we'll be posting the recording along with other materials in a link under this heading on the learning page. So come back to the learning page to see the webinar again. Okay, so today I'm going to start with a brief introduction to SAM in general, and then we're going to go through two examples. I'm going to present an example of how to model a small wind project in SAM, and then Tom is going to show us how to model a larger wind farm. And then we'll spend a couple minutes talking about some additional topics and hopefully have time for questions at the end. We're scheduled for an hour. If we need to run over 5 or 10 minutes for questions, we can do that, but we'll try to finish up within the hour. So SAM is a computer program, and it's designed to model renewable energy projects, and it basically combines a performance model that calculates a renewable energy system's electricity production over a year with a financial model that calculates a project's cash flow over a period of several years. And using the results of these two models, you can evaluate the financial feasibility of a renewable energy project. SAM can model a range of renewable energy technologies, photovoltaics, concentrating solar power, so parabolic troughs, power towers, and so on, and wind, which is what we'll be discussing today, and also geothermal and biopower systems. SAM's performance and financial models are based on, or adaptations of models that were developed either in the National Laboratory System at NREL or Sandia or others, or at some universities. And these models, before SAM was around, were basically used in-house as research tools, and SAM has made it possible for those models to be used by the general public. And one of the main purposes of SAM is to make it possible to model different types of renewable energy systems using a consistent set of financial models. So you could compare a wind power system to a solar power system, for example, and know that the financial metrics that you're using to compare the two projects are consistent because you're using the same financial model with different performance models. This slide just sort of illustrates the sort of dual nature of SAM, that it has a performance model, which is here on the left side. This is a list of the performance models that are included in SAM. And then the financial model, which is here on the right side, shows you the kinds of projects you can model in SAM, so residential and commercial, and also utility scale projects. And then course, the financial model handles project costs, incentives, debt structure, and those sorts of things. So SAM is developed by the National Renewable Energy Laboratory with funding from the Department of Energy, and is also, we partner with Sandia National Laboratories and other institutions. And we have well over 35,000 downloads of SAM by a range of different kinds of institutions and individuals. Just in case you haven't done this yet, to download SAM, you go to the SAM website, sam.nrel.gov, and you have to register on the website before you can download SAM. To register, you just complete a short form, and then you can log on to the website and download. So when you're logged on to the site, you'll see a list of links to download SAM. Again, SAM is free, so there's no charge for downloading or using SAM. All right, so let's, I guess one more thing is we've got a bunch of resources to help you learn to use SAM and help you when you have questions as you're using it. The first sort of line of defense is the help system in SAM. So there's a help system integrated with the software. You can press the F1 key in Windows or this question mark button in the user interface to open the help system. The SAM website is also a good source of information about SAM. It's searchable, and there's a user forum that has questions that users have posted to the forum along with answers to the questions by members of the SAM team. And then there are also links to numerous publications that either document the models that SAM uses or that document analyses that have been done using SAM. And finally, we have an email address, sam.support@nrel.gov. If all else fails, then you're always more than welcome to send us an email. And we monitor email in the forum on a daily basis, so you should get pretty quick answers within a day or so of posting questions or sending us an email. Okay, so I'm going to start with an example of how to model a small wind project in SAM. And this slide shows the basic assumptions that I'm going to be using for this example. It's going to be for a project site in North Central Oregon, which I've just chosen arbitrarily. And I'm going to model a wind project with one Vestas V47 wind turbine. And this turbine is going to help meet the load of a small farm. So the project is buying and selling electricity at retail rates. And the wind turbine is displacing electricity purchases from the utility. So the farm is going to try to reduce its electricity purchase costs by installing a turbine on the site. And I'm making some assumptions here about the retail electricity rate. The farm purchases electricity at 8 cents per kilowatt hour, and it can sell at 5 cents per kilowatt hour. And I just made these numbers up. It's not based on any real rates. I'm assuming an installation cost of $5,000 per kilowatt, and it costs $10 per kilowatt annually to operate the wind turbine. And then I'm assuming that the project is financed with a 60% loan, and that it can take advantage of the federal PTC. So these are the assumptions that I'll be putting into the model. So let me move this aside and get SAM up. With any luck, you can see the SAM window. And just a tip for the My Meeting session, in the bottom right corner of your screen, there's a little Fit Full Screen Mode button. You may want to click that if you want to see the entire screen. Some part of the screen may be cut off now if you're not in full screen mode. All right, so this is what you see when you first start SAM. It's the welcome window. And to start an analysis, you first create a file, and you can do that either by typing a name for your project and clicking Create New File, or I like to use the File menu and click File New. The two are equivalent, so File New. When you do that, then you get a list of the performance models that are available in SAM. So we're modeling a wind system, so we choose wind power here. I just click wind power. And then once I click wind power, I get a list of the financial models that are available for the wind power model. And we're looking at a commercial project here. So the farm on which the turbine will be installed is a commercial facility. So I'm going to use the commercial financing option here. There's a description of all the different model options in help. If you click help down here, you can see that. I'm not going to go through all the options here. We'll just focus on our example. So wind power, commercial, then I click OK. And then SAM opens up a file with a default case. So I have a case called New Wind Power Case 1 here. And on the left side of the window here is a navigation menu with buttons that you can click. And as you click the buttons, SAM displays different input pages. So you can see that there are a lot of input pages and that each input page has a lot of inputs. But you'll also notice as I'm flipping through here that all of the inputs have default values in them. So right when you start, from the time you create your file, you're actually ready to run a simulation. So I can just click Run here, and I have results for the default commercial wind system. So I haven't entered any values here. I'm just working with the default assumptions, and get a system with reasonable results. So if you're just getting started with SAM, you can just start with the default system and start, changing different inputs to familiarize yourself with them. And again, check help for details about what the inputs mean. There's a lot of information in help. Okay, so for our system, I mentioned that it's in north central Oregon. So I'm going to start at the top of the navigation menu with the wind resource button. This is where I tell SAM what wind resource data to use for the project. And I'm going to make the screen a little bigger here so you can see it. We've got a few options here for wind resource data. What I'm going to do is use one of the files that are included with SAM. These are what we call typical wind data files. And they're data for specific locations in the U.S., but that we've sort of chosen to represent the range of types of wind resource that you might see in the U.S. So these files are okay to use for sort of a very preliminary analysis before you've started collecting data, if you just kind of want to get a sense of what the wind resource might be like at a given site. Obviously, you're not going to want to make any financial decisions based on these typical weather files. For my example, I'm going to use the typical weather file. In Tom's example, he's going to use what we're calling now location lookup, which provides access to a different set of weather files. So you'll see that in a moment. It's also possible if you have your own wind resource data, if you have measured data, it's possible to create your own SRW file. So that's a text file with wind resource data in it. And there's instructions for how to do that in help. So for now, for my system in Oregon, I'm going to type OR here to filter the files to sort them, or just show the files that have Oregon in their name. And I'm going to use this Oregon Northern Flatlands file, because that's roughly represents the kind of terrain where my wind farm is, my wind turbine is. And I just clicked F1. If I look under representative typical wind data files in help, there are pictures of the different terrain types. So the flatlands terrain type looks like this. It looks like flat land, surprisingly enough. So that's what I'm going to use for my example. And when I select the file here, I can see some basic data, summary data about the the data in the file down here. All right, so now that I have my wind resource data specified, I'm going to pick a turbine. So I go to the turbine page. I'm going to use the select turbine from our list option, and which is the option that you're going to want to use for most project analysis. And that gives me a list of wind turbines. And I mentioned that I was going to use the Vestas V47. So I'll go down here. There's Vestas V47, and that's all I have to do. I have the power curve of the wind turbine. And you may have also noticed here that SAM displayed an error message in red. It's telling me that the hub height is too low for the rotor diameter. So this turbine has a 47-meter rotor diameter, and the default hub height is 25 meters. So the tower is shorter than the rotor. That's not going to work. So let me give it a hub height of 50 meters. And now the message goes away. And then I'll go down the list here to wind farm. This is a single turbine, so I want to make sure that use more than one turbine is clear. This checkbox is clear. Number of turbines is 1. And then I can just ignore the rest of these because I'm not laying out a wind farm. Tom, again, will show us how to do that when he models a wind farm. The next set of inputs are these performance adjustment inputs. I'm going to ignore them for this example, but just so you know, these are here so that you can model the effects of curtailment. If you're required to shut the wind farm down during certain times of year by the utility, or to account for downtimes for maintenance and that sort of thing, you can use performance adjustment inputs to account for that. All right, wind system costs. I'm not going to skip that. That's an important input. And the way we have the default set up for the commercial wind power system here is that we're just using a single cost to represent the project's installation cost. So you'll notice there's a bunch of categories here: turbine costs, foundations, infrastructure, and then we've got some indirect costs. And they're all set to 0 by default, except for the turbine cost. So SAM only uses one number to represent the installation cost, and that's this total installed cost that you see down here under total installed cost. So SAM calculates this number by adding up all of these different cost categories. And so it doesn't really matter how you assign costs to the different categories, as long as the total installed cost is what you expect it to be for the project. So to keep things simple, we've just used the turbine cost to represent the total cost, and then we've added an 8% contingency cost here. So I said that the total installation cost is $5,000. And then, so that gives me a total installed cost of $5,670 per kilowatt. And then I also mentioned that the operating cost is $10 per year, per kilowatt, $10 per kilowatt per year. So I'll put that down here. You can also enter O&M costs in different units, so as dollars per year or dollars per megawatt hour. Okay, so we need to tell SAM both what it costs to install the system and what it costs to operate the system. All right, so that's wind system costs. Next, we go to financing. And here, the only detail that I gave about financing when I listed the assumptions was that the debt fraction is 60%. So it's a 60% loan. And for now, I'm just going to go with the default values for the other assumptions. Obviously, these are important and are going to vary from project to project. But just to get me started, I'll say I have a 60% debt fraction, and I'll use the 7.5% interest rate for the loan. And then we've got inflation and discount rates here, which SAM uses to calculate net present value and levelized cost of energy. And then I've got some tax assumptions here, and I'm just going to go with the defaults. And then for incentives, I said the project benefits from the 2.2 cent per kilowatt hour PTC. That's in there by default under PTC. And you'll notice there are inputs for a bunch of other incentives, which are all set to 0 by default. So for a project like this, a wind turbine on a farm is likely to benefit from a bunch of other incentives. There are probably state-level incentives. There may be federal incentives, for example, from the USDA that apply to agricultural facilities. The county may offer incentives. The utility may offer incentives. So you can put the whole package of incentives that the project can benefit from in these inputs. I'm just going to keep things simple now and assume that only the PTC applies. Now, I want to take a quick moment here to talk about the Desire database. This is a website that lists renewable energy incentives for each state in the country and also for federal incentives. We can see the website by clicking the link here. Go to website. You may be familiar with this. If I click Oregon, I get a list of all the incentives that are available in Oregon. But I can use this website to find out what incentives my project can use. But I also, theoretically anyway, can use this download incentives button to automatically get data from this Desire database. But if I do that, I get a message that says no Desire incentives found for the location and technology. That's Sam's way of telling me that it doesn't have location data for the type of weather file that I used. So when you click download incentives, what Sam does is it goes to the wind resource data and looks for the latitude and longitude to figure out where the project is. But since there's no latitude or longitude data in this particular data file that I chose, Sam doesn't have the information it needs to download the incentive data. So these typical wind data files that come packaged with SAM don't have location information. But if you use location lookup, as Tom will show you in a moment, then you will have latitude and longitude data, and then the download incentives button will work. All right. Next, let's look at depreciation. So that's the next window. And I'm going to go with the default. So this farm is a commercial entity, and I assume that it can take advantage of the accelerated depreciation under IRS rules. And we're just going to go with the 5-year schedule. Okay, now we get to the utility rate. So remember I said this is a project that's buying and selling power at retail rates. So on the utility rate page, we tell Sam what the rate structure looks like. I'm going to use a simple rate structure, again, that I just made up. So I'm going to go through and clear all the checkboxes for these complex rates. I said that the farm buys electricity from the utility at 8 cents per kilowatt hour, and that the utility is willing to buy extra electricity that the farm generates at 5 cents per kilowatt hour. Again, we have an online automatic download from an online database feature for the utility rates. So if you click that button, then Sam tries to get in touch with a server, which it often can't do on its first try. So if you get that message, you just try again, click refresh, and usually it comes up the second time. There we go. There's a list of all the utilities in the United States, or at least a whole lot of them. And if I filter the list there by typing Oregon, there's a list of utilities that happen to have the word Oregon in their names. And so then if I click, for example, Pacific Corp, here's a list of the utility rates that are available from Pacific Corp. And so I could use this to download a rate structure automatically, whichever one applies to the farm. So I just want to show you that's available. I'm not going to use it for this example, so I'll just click close. By the way, once you make your choice here, once you choose a utility rate, then you click download and apply utility rate, and then SAM populates the utility rate page. But we're just doing a simple flat rate with a different buy and sell rate. If I'm modeling this kind of a system, since I've got a different different buy rate and different sell rate, I need to give Sam some information about the electricity usage of the farm. So that I do on the electric load page. And I'll be the first to tell you that the electric load page is a little tricky to use. So if you're working with electric load data, feel free to get in touch with us via the forum or by email. I'm going to show you how to work with one of the sample load files that we include with SAM. So here goes. And I'll also mention that the steps that I'm walking through here, obviously you'll be able to go refer to the video when we're done to look back at what I'm doing. But I also will be posting a PowerPoint presentation that kind of steps through what I'm going through here. So don't worry too much if you're not following all the steps that I'm going through here. I'm about to launch into a bunch of complicated steps. To load a file of load data, I click user entered hourly data here, and that makes the edit data button active. So then I click edit data, and then I click import in the edit data window, and I navigate to this folder in the SAM installation folder. So by default in Windows, SAM installs itself in CSAM 2013.1.15. And then in that folder, there's a folder called Samples, Simulated Electric Load Data, and it has a bunch of text files. These text files are just a single column of hourly electric load data in average kilowatts per hour. And I'm arbitrarily here going to choose Medford. I think Medford is the town in Oregon, so I'll just use it for fun here. Basically, in order to model load data in SAM, SAM needs a set of hourly data. So I need some kind of hourly data file to use. So I'm just going to use this Medford text file. There's the hourly data from the file. So you can see it goes all the way to 8,760, which is the number of hours in a year. When I click OK, then this table of monthly values is populated. So I can see the monthly energy and monthly peak load. And then I see the annual totals here. Now my farm has a much bigger load than this. So I'm just going to scale this hourly data up by a factor of 100. So I put 100 as a scaling factor. Whoops, not 1,000. And now the annual peak is 320 kilowatts, and this farm consumes 716,000 kilowatt hours per year. I'm going to just use that as a first approximation of the farm's load, and call things good. So now I've put in values or reviewed the values on each of the input pages. I'm ready to run, and that's this green arrow button is the run button. So I click run, and Sam just did a year's worth of hourly simulations and displayed some results. So down here under the run button is what we call the metrics table, and this is a summary of the results from SAM. We also have graphs and tables of data. So right now I'm looking at graphs, and we've got a graph of monthly output and a graph of the cash flow. I can click the thumbnails down here to show the graphs one by one. Control click to choose more than one graph. But the monthly output and after-tax cash flow are kind of a good summary of the system's performance. If I want to dig into more detail, I can look at tables and expand the list to show different outputs. There's a cash flow table here. This shows the detail of the project cash flow, so I can see what's going on with my cash flow. And then the time series graph shows graphs of the hourly data. So I can choose a variable, zoom in, look at the data using in different formats. So I encourage you to play around with these to see. There's lots of different ways to show results in SAM. And in general, you can right-click graphs to export images of them if you want to put them in a document or a presentation. You can also export data using these copy to clipboard or send to Excel buttons. So there's lots of different ways to get your data out of SAM and into other applications. So let's look at the our results here. So this Vestas 660 kilowatt turbine produced about 1.5 million kilowatt hours in a year, and I have a LCOE of 13 cents per kilowatt hour. And the total revenue for this system is about $30,000 per year. The revenue without system is basically what I would be paying for electricity without the system. So my net revenue is the difference between the two. And then I have a negative net present value, which is not a good sign. If I look at the cash flow graph, I can see that my initial cost here in year zero I have a big negative here in year zero, and I have a little bit of positive here in the first 5 years. This is from accelerated depreciation. And then my operating costs in the out years are basically I'm not getting enough revenue to meet the cost of the system. So I have a negative net present value. And I also have this strange number and letters in payback, which is telling me that the payback is longer than my analysis period. I have a 25-year analysis period, and the payback is longer than 25 years. So based on my assumptions, this project doesn't look very good. So what I want to do now quickly is to show you how to do a parametric study on I'm going to do it on the system cost. So my turbine cost is $5,000 per kilowatt. I want to look and see what happens over a range of turbine costs. So I'm going to go through these steps quickly, but you can get step-by-step instructions and help and on some of the other videos on the learning page of the website. So go to parametrics, click Add Parametric Simulation, Add Turbine Cost. Okay, and what a parametric analysis allows me to do is to put in a range of costs, a range of values for any input variable. So now I'm going to model my project with 1, 2, 3, 4, 5 different turbine costs. Okay, so there's my 5 simulations. And then I want to plot a graph of net present value versus turbine cost. Okay, I'll make that a line plot, and I'm going to get rid of my labels here. Okay, so what this shows me is that I've got turbine costs on the x-axis, ranging from $1,000 per kilowatt to $5,000 per kilowatt, and I can see that this is net present value on the y-axis in dollars, and I can see that the net present value line crosses zero at somewhere between $1,000 and $2,000 per kilowatt. So what that tells me is for this project to be to make sense financially, I need a turbine cost of less than $2,000 per kilowatt. So that means I need incentives. I either need incentives or I need to buy a cheaper turbine, or I need to do something to get the turbine costs down. Obviously, I could change other assumptions. I could look at a different wind resource regime. I could change some of the other financial parameters. But if I only look at turbine cost, this graph gives me a picture of the impact of the turbine cost on the project feasibility. If I go back and change the system cost to, let's say, $1,000 per kilowatt and run, Now my metrics table shows a positive NPV, a payback period of 6 years. So that's a much more reasonable looking project. All right. So let me stop talking now so Tom can show you how to model a wind farm. And maybe we can pause a moment if there are any questions about the commercial system. So Tom, why don't you go ahead and take over.
Hello, this is Tom. Thanks for participating so far. Paul has done a great job of introducing a lot of things that are very similar, so I'm not going to repeat any of the basic things he said. I'm going to sort of highlight things that are maybe different about doing a wind farm versus a single turbine. So I have a similar slide to Paul's that outlines the project I am going to try to model, and it's sited in north or southeastern Wyoming. I'll have it using 30 GE 1.5 megawatt turbines on 80-meter towers. So this farm is going to provide power to the grid, and we expect if we can, get a PPA signed for $80 per megawatt hour or 8 cents per kilowatt hour. And we actually think that we can get a 10% bonus during peak periods in the summer. So I'll show you how we could maybe model that too. The total installation cost per kilowatt is going to be just under $2,100. And the operation and maintenance costs $50 per kilowatt per year. And we expect this project as well to get started in time to take advantage of the federal ITC. So, and finally, the question we're trying to answer with this one is, will it make, we want to have our company typically has a goal of making a 12% internal rate of return. Will this project make it, first cut, are we close or are we way off, that kind of thing. So now I'm going to share my version of SAM and go hopefully straight into a live presentation. Okay. So like Paul, we'll start, I usually click the button, so I'm going to create a new file. And instead of choosing the commercial, I'll choose the independent power producer. And as Paul mentioned, this is going to set up a new one that I could run immediately because it has all the default values in it. Since Paul showed you that, I'm not going to bother doing that. I'm just going to start changing the things I want to change. So this, I happen to have a Cheyenne, Wyoming one, which is close. But I want to demonstrate real quick the location lookup. So I click that, and see here, it's thinking. All right. So the database for the wind is, by the way, it's much more complete in the western half of the United States than it is in the east. So there's a lot of sites in the western half, very few in the east at this point. Now that's hopefully in the next 6 months that's going to change because we're looking to get a better database. So since I have the right, location, but maybe I wanted to choose a different year. So just for the demo here, I'll choose 2004 and click OK. So SAM is connected to a data server, and I think the grid here is around 10 kilometers for the western half of the United States. So there's a fair amount of wind data available through SAM like this. So it's downloading the data, and now it's parsing the file, which takes it a few minutes. No, not a few minutes, under half a minute probably. And it gets all the values out of it, and then it'll update the displays here to show you what the file is. Okay, so it retrieved the data successfully. And now by changing if I click on, this one has a wind speed about 7 meters per second, and in 2006, it was 7.2. I'm looking there. So you can get a quick view of how they're different by just clicking on the different values. I could click View Hourly Data and get a detailed view of everything that's in this file, graphically, or you could just open up the file. It's telling me where it loaded it. This is just a text file. There's nothing special about it. You could open this with any text editor and look at it. It's about 8,760 lines long, and it has, I think about 18 columns, and you can use it for whatever you want. But Sam knows how to read it right away and can use it for this. So the turbine, I said I was going to use a 1.5 megawatt GE, so I'll go find that from the list. Paul, again, has done this already, so I'm not going to go into details, but you can see that. I've chosen it from the list. If you just click the up and down arrow on here, it'll update these graphs immediately on my screen or on your screen if you're running it. Probably takes a little while over the webinar. But so you can see exactly what they are, and you can flip through them all very quickly. Incidentally, I want to bring up a certain point about SAM and the wind model in general right now. This option here is for sort of designing your own turbine. You can see here, if I change this, I've modified the whole power curve here. In general, this combined with a couple of other options on different pages. Let me go back real quick. See, this option here lets you input power and wind resource in a different way. These are part of a sort of an R&D, you might call it not sub-model, but modeling capability within this model. We wouldn't generally say that most users are going to want this. It's here mostly for NREL R&D people to use. So although it takes up, all these things take up a big part of the screen, they're not actually, we don't expect people typically to use them. If you're into the R&D of turbines, please contact us and ask for help, and we can maybe help you use this. But don't expect to use those things very often. So we're going to stick with this GE 1.5 and use its standard turbine in the library. Incidentally, also, the library is relatively simple. It's just a text file with a bunch of numbers in it. You can relatively easily add your own to it. So if you need help, contact us, but it's relatively straightforward. So then the next thing is to implement the wind farm. There's right now, SAM will only let you choose from certain geometric shapes. In the near future, actually, I'm expecting to change the code to allow you to input your own XY coordinates so you can put in whatever farm you want to. That's probably going to change here in the next couple of weeks, and then it'll be on the next release, which might be later this summer or fall. So we make sure this is checked so that we can use these inputs. And I said I wanted to have 30 turbines. I'm going to have 10 turbines in 3 rows. Now, in southeastern Wyoming, the wind is typically coming from the west, so you'd probably want to orient this thing to catch wind from the west the best as possible. So you can change the orientation here. And in this part of the country, I'm not sure if you've been there or not, but there's a lot of ridges, and oftentimes these are installed on tops of the ridges as best as possible. At least you would if you could. So to make this long and skinny, what I'm going to do is offset the rows. Instead of just a little amount, I'm going to offset it by a larger amount. And there. So now we have, if our ridge happens to be going the other direction instead of going up like this, it's going maybe back or something like that, you can offset by a negative number and you'll get something that looks like this. So there we have a farm that's oriented on top of a ridge, with the wind we expect to be coming from the slightly north of straight west, so that we capture it as much as possible with as few turbines being in the, the wake of the turbines in front of them. Incidentally, you could, like Paul showed, doing a parametric. You can do a parametric on the orientation of the farm and see if it maximizes. Having played with it, it doesn't seem to change a lot unless you really orient this thing so that the wind is always coming straight down the road. So for farm losses, I'm just going to put in 5%. SAM uses the turbine layout actually to do wake losses. It calculates its own wake losses. So it's doing a relatively simple analysis as the wind flows through the farm of what turbines are behind what other turbines, and it's adjusting their losses accordingly. So don't include your wake losses here. So I'm just putting in a number to start with here. It's sort of an arbitrary number, 5%. The performance adjustment, Paul already talked about this, so I'm not going to go through it in detail. Wind system costs. I'm going to accept the defaults here, which work out to be, let's see, about what I said. So this one has all the details filled out. These numbers come from some reports from NREL, so these are, what NREL thinks are reasonable assumptions. Again, it's not for a specific project, it's for, a general project. So I guess the value, again, that Paul mentioned is the main important one, which is total install cost, which you can divide by kilowatts to get the cost per kilowatt. So by having cost per kilowatt would allow you to do a parametric on the size of the farm, for instance. If you wanted to do a parametric on multiple rows, different numbers of rows or different numbers of turbines, then having the cost per kilowatt means the cost would scale up automatically. And SAM will do that. So I'm going to accept these defaults. They're fine with me. For this one, we said we had a PPA price. We expected to get about $80 a megawatt hour, and we're going to see what the IRR is. So I'm going to type in the $80 or 8 cents per kilowatt hour, and then we'll see what the internal rate of return the SAM calculates is. I think there's one more thing that I wanted to do here, because I'm not going to go into the depreciation. I'm going to accept the default depreciation and incentives. But the time of delivery, so we said we had a bonus for delivering during peak hours. Let's assume that the peak hours in Wyoming and the Colorado area are the summer months in, from 1 to 6. What I can do here is say, okay, during those times I get a little extra revenue. I said a 10% extra. So first I want to change these to be, to use this second period number, which is, right now it's 1, but I'm going to change this to 1.1. Oops. Not 11.1.1. And then I'm going to say, the way I tell SAM to use this is I say, highlight what I want, and then just type the number 2. And that changes all these to 2, so that during these times, SAM will be using this factor instead of just 1. And then I'm ready to run this. So see where we get. Let me move this over. And okay, so we were at 11.53. We're not quite at 12%, and we could easily do a parametric analysis, as Paul showed, to decide on different factors to say, okay, maybe a different loan amount would change it to the internal rate of return tends to be pretty sensitive to it. I can do it very quickly by going up here and saying, well, no, it's not 50%, it's 55%. And then run it again since it runs very quickly. Okay, so now we're at 12.9. So somewhere in between there, between 50 and 55, the amount went over, the internal rate of return went over 12%, and you could do a parametric, as Paul showed, to decide where exactly that happened. Or, you can do a parametric on other things. You can do a parametric on different efficiencies of the wind farm assumptions that I put in for 5%. Maybe we could run it from 3 to 7% or whatever, find a different answers for those different input assumptions. So I think since Paul went through, and we're about 10 minutes till, and we wanted to have some time for questions, I'm going to stop here since Paul has already talked about the cash flow and everything. And he's allowed people to ask questions about any part of this. And if we don't have questions right away, I think we will. Paul wanted to talk to the few other topics that we can talk about, some more advanced topics that are like the parametrics that we can show people. Or if people have detailed questions about a specific thing, we can go into that too.
Great. Thanks, Tom. I think there's a couple of questions already in the chat window, so maybe I can address those, and then we can open the floor for questions by voice. So there's a question about where to get reasonable estimates for installation costs and O&M costs. That's a good question, a question that we often get, and unfortunately a question that we don't have an excellent answer to. I can refer you to a couple of resources, the first being on the SAM website. under resources here, there's system cost data. And we try to, as we become aware of publications with information about costs, to post that links to those documents here. So we go down under wind. There's some references here. And these tend to be sort of high-level analyses of costs throughout the U.S. There are, the American Wind Energy Association, AWEA, and some other organizations also have information about costs. There are a few different websites that have pretty good documentation of costs for small wind, and often state energy offices have websites in states that are actively promoting renewables. You can often find good information on the state energy office websites. Of course, the NREL publications database is another good source of information on research that NREL is doing on costs. Unfortunately, there's not a place where you can go to find out how much it's going to cost to build your particular project, because that actual costs depend a lot on, particular vendors and the kind of entity that you're representing and so on. So there are a lot of factors that affect specific costs of a project, but some of these resources can help you get started with preliminary analyses. Let's see. There was a question about the SRW file format, which I answered by typing, but I'll just reiterate. This SRW file format is just a text file. I'll see if I can find a file to open. And you need not just wind speed data, but you need direction data, temperature data, humidity.
I think it's just pressure, Paul.
Pressure.
Pressure,
okay.
Temperature, wind speed, and wind direction.
Great.
Now, the pressure and temperature, if you don't know them, you can put in reasonable estimates for them, right? You can say it's 15 degrees Celsius all the time, and the pressure in bar as whatever normal, and just fill the whole column full of that. And then you can run it with just the wind speed and direction, but it does need direction, because otherwise, unless you're, well, I think it still needs direction. Even if you're running one turbine and direction doesn't matter, I think it still looks for it. Well, that's something I can probably change. So, if you are just running one turbine, though, and you have the wind speed, you can just fill a column full of zeros or ones to make up the direction, because it's unused anyway. So you could do a single turbine analysis by just having 3 columns of sort of made-up numbers and 1 column of wind speed.
Yeah, thanks, Tom. And this is just what the SRW file looks like. It's a text file with a few rows of header data and comma-separated files. And it's a pretty flexible format. It's described in help, but you can specify. You should have at least one, a set of pressure, temperature, direction, and speed data at one height at least, and then at more heights, preferably. So it's pretty easy to create one of these files or to modify one. If I go back to...
Yeah, it's almost a default from Microsoft Excel. If you choose to save something in Microsoft Excel that has comma-separated values, then you'll get just about that if it has that data in it in the cells. So.
Okay, and then here's the description of the different weather file formats that Sam can read. And SRW is hopefully down here somewhere. There we go. So we have a description of the format and units and so on.
Yeah, as a matter of fact, we wrote the format such that if you change the file name from SRW to CSV, Excel will open it, you can look at it, and then you could change the numbers right there in Excel, and then save it as a CSV and change the name back to SRW, and I think you'll be in good shape. It'll be really close if you're not. It'll be almost perfect. So
All right, are there any other questions? Maybe we could open the floor. Operator, are there any questions in queue?
If you would like to ask a question, please press star 1, unmute your line, and record your name. To withdraw your question, press star 2. Once again, to ask a question, please press star, then 1, unmute your line, and record your name. One moment.
And while we're waiting, Tom mentioned that you can look at your resource data by clicking the View Hourly Data button here. And so I just wanted to show you that. So this shows you the data that's in the particular weather file that we're looking at. So it's got data at 50, 80, 110, 140 meters, and you can see there's temperature, pressure, direction at each, and the wind speed at each height. And you can use these checkboxes to plot the data. We can look at PDF of the wind speed, and so on. Okay. Do we have any questions?
We have no questions at this time.
Okay. We showed you the configure simulations window here for parametric and other studies. There's you can look these, if you're on any of these pages and press the F1 button, you get some help about what you can do with them. But there are these advanced analysis capabilities in SAM. So once you've kind of familiarized yourself with the basic simulations, you can explore these for other options. So if there are no questions, I think that's all we had for today.
Well, we do not have any questions at this time.
None in Q&A. Okay. Well, then I think we can call it a success. Thank you all for your participation. Remember to visit the learning page on the SAM website to download a recording of this session and other materials. Feel free to share those with your colleagues. We'll be back.
When's the next one, Paul?
Yeah, go ahead.
When's the next one, Paul?
Yeah, we'll be back in 2 weeks for the next webinar. Let me pull up the schedule here. So on the learning page of the SAM website is the schedule for the next one. So the next one is June 19th. We'll be talking about the PPA financial model. So that's the financial model that Tom used for the wind farm model. We'll talk about the financial aspect in detail on the 19th. And then on July 10th, we're going to talk about the residential commercial financial model. So if you're interested in either of those financial models, be sure to join us on those days. And then on the 24th, we'll be introducing the SDK for the programmers among you. All right. So thanks again. I think we'll sign off.
Thank you.
Thank you for participating in today's conference. You may disconnect at this time.